All right, guys, first lesson in Unit 2 are going to be about relations and functions. It's going to be a little vocab heavy, so make sure you write these down so you'll have them in your notes and you won't forget what these words mean because you know you're going to be quizzed on them. All right, so the first word is relation. So a relation is just any pairing of input and output values. Okay, so anytime you have inputs on the left, outputs on the right, and you kind of pair them up, that's a relation. Okay, we're going to talk about more special types of relations here in a second. Okay, the domain are the set of all inputs. So whatever is in the input side, we call that the domain. And then consequently, the range is the set of all output values. Okay, so whenever you input the domain, the range is what you get out of that, whatever the relation says. So we have a little mapping here. That's what this is called. It's a mapping of a domain to some range values. Okay, so a bunch of different ways you can express this. So mapping is one way. You can use a table. Usually in a table, we refer to the inputs as x and the outputs as f of x or y. And so on this one, I'd say the x is 2 and the range is a, and the x is 2 again, and the f of x is b, and the x is 2 again, and the f of x is c. We could list out a set of points. So I could do 2 comma a is a point, and 2 comma b, and 2 comma c. All right, sometimes you're just asked to list the domain. So what's the domain? Well, in this one, there's only one, 2. All right, list out the range. All right, well, in the range, we have A, we have B, and we have C. Okay, and notice how I'm listing these sets out. These are sets. We've talked about sets like real numbers and rational numbers, but really any grouping of numbers that you come up with is called a set. And you usually put sets in the brace. We talked about set notation. This isn't exactly set notation. This is called roster notation. Roster notation is where you just simply list out every element in that set. Okay, and as long as you put them in curly braces, that's what denotes that they're a set and not just some random grouping of things that you put together. All right, so let's find the domain and range of each relation here. All right, so this first one gives us a set of points. Okay, so we're going to list out the domain and the range. All right, so remember, domain are all the inputs, which means they're all the x values. So that's 100 and 120 and 140, 160, 180. Okay, and we're just going to list those out in roster notation. Since they're just 5 particular points, we don't want to put like x is greater than 100 and less than 180 because that's not true. It's not every number between those. It's only these specific 5. All right, when there's only 5 things like this, it's just easiest to just write them all out. Okay, now you'll notice with the range values, we've got a couple of repeaters. We've got 5 twice, we've got 6 twice, and we've got 12. Okay, when we list them all out, you don't have to list them twice. Just list each individual item once. So there's a 5 in the range, there's a 6 in the range, and there's a 12 in the range. And that would be it. All right, y'all try to list out the domain and range on the graph, and then unpause the video and see how you did. All right, so the domain, all of our x values. So what I like to do on these is just kind of map them down to the x-axis. So there, that's on the x-axis here, here, and here. All right, so I always start with the least and go to the greatest when I'm listing things out. So that's -2, -1, 0, 1, 2, and 3. All right, and then with the range, do the same thing, except I'm going to map them over to the y-axis. Okay, start with the least, so -3, -2, -1, 0, 1, and 2. All right, so a special kind of relation is called a function. All right, now you've talked about functions plenty before in Algebra 1. Okay, functions are the biggest part of this class. We're going to cover many different types of functions, some that you've seen like linear and quadratic, others that you don't know about like radical and rational. Okay, so a function, the definition is a relation, but it's a relation where each input has only one specific output. So basically that means that anytime you input a number, you only get one number out. You can't possibly get two separate numbers out, all right, or letters or whatever the output is. Okay, so let's talk about what that means. Okay, if I give you a set of points, for it to be considered a function, you need to make sure that set of points has no repeated x values. So for instance, if we go back to this page, see how all of our x values were different? This would be considered a function. Now there were repeated y values, but that's okay. You're allowed to have repeated y values. Okay, just no repeated x values. All right, that's what makes it a function. All right, you may have talked about the Coke machine example. Coke machine is almost a perfect example of what a function is. Okay, you go up to the Coke machine, you put your money in, and you click whatever you want. So the person in this picture is clicking that they want a Coke Zero. So what's going to come out of the bottom? Well, that person hopes they get a Coke Zero because that's what they paid for. So if a Coke machine was not a function, when you click the Coke Zero button, you could get out a Sprite. Okay, and that's not going to make you very happy. Okay, so we want things to be functions. We want them to have one specific output. Okay, if we were able to click that Coke machine button and get out just any random soda, okay, that's not going to make us very happy, and we're not going to go back to that Coke machine. We're not going to give it our money. Okay, so we want things to be functions. We want to have one specific output. So let's take this back into a math realm. Let's look at these mappings. Now this one on the left is like the one we had on the first page. Okay, each input has only one specific output. So if I go up to the Coke machine and I click 2, does it know exactly, do I know what I'm going to get? I do not. So if I go up and click 2, let's say 2 is the Coke Zero button. Okay, I could be getting out an A, which could be a regular Coke, or I could get out a B, which could be our Coke Zero, or I could get out a C, which could be Sprite. So I don't want to give my money in there, click my Coke Zero button, and have one of 3 options that I could get out. I couldn't even get what I want. So this would be not a function. All right, and we don't want that. Not a function. FXN is kind of how you abbreviate function. So what about example 2? So basically just flip it around. Have the ABCs in the domain and the range in 2. Okay, so is this a function? If I go up and click the A, do I know what I'm going to get? Yeah, I'm going to get a 2. Okay, if I go up and click the B, do I know what I'm going to get? Yeah, I'm going to get a 2. Okay, same thing with C. So if you look at this Coke picture again, see how there are 2 Coke buttons? Okay, that's like this example. So if I click the first one, I know I'm going to get a Coke. If I click the second one, I'm also going to get a Coke. So it's 2 inputs pointing to the same output, but we know exactly what that output's going to be. We know we're going to get a Coke when we hit that button. We're not going to get some random Diet Coke or Fanta or whatever. Okay, so as long as they're only pointing to one item in the range, then yes, this is a function. So you're allowed to have multiple inputs point to the same output, but you're not allowed to have one input point to multiple outputs. All right, that's the difference. All right, so what if I give you a graph and ask you the same question? Are these functions? Okay, there's a test that you probably remember. It's called the vertical line test. So anytime you're given a graph, you should be able to draw vertical lines all over the graph, and you should never hit more than one point. If you ever hit a point more than once with a vertical line, it's not a function. So see on this one, I've drawn a bunch of vertical lines. I never hit the graph more than once. So this is considered a function. All right, I want you to try these other 3, determine if they're functions or not functions, and then unpause the video and see if you got them right. All right, this one on the right here, we've got 2 different lines, but if we consider them as like all one graph, if I draw a vertical line, see how I'm going to hit 1, 2. Okay, that tells you right there, not a function. All right, this one over here, drawing vertical lines all over this. Very similar to the first one. It's got a curve in it, but it is a function. All right, then this last one. This one's kind of tricky because we can draw vertical lines all over here and all over here, and we're fine. But at one particular spot, right here, I cross through 2 points. 1, 2. So this one would be considered not a function. All right, now how could we change this graph and make it a function? So you'll see a lot of graphs like this. There's a function called the greatest integer function, which basically has a bunch of line segments. It looks like some stairs, like steps. It's often called the step function. Okay, so it's like a line segment, and then you go up, and it's another one, and then you go up, and it's another one, like that. All right, so how do they call that a function if there's a point here and right on top of it? The way that they fix this problem is they make one of them an open circle. So remember, an open circle on a graph signifies that that point is not there. So now if I draw a vertical line, I'm not crossing through a point here. I am crossing through a point here. So that's only one point. So if they would have made this an open circle on the end, then this would have been a function. But as drawn with two closed circles, it is not, because you're going to cross through 2 points right there. All right, last thing we need to talk about is function notation. Okay, so that's the f of x notation. Y'all know that is the same thing as y. So if we were writing it in point form, xy is the same thing as x f of x. Okay, and if you substituted for y, it'd be x and then 5x plus 3, because that's the equation given here. So you can just replace that in the y spot in the point. So notice that this does not mean f times x. It looks like it because it's in parentheses, f times x. That's not it. This notation means f of x. All right, the value of f where at x. So if I say what is f of 1, you want to plug in 1 for x and figure out what that equals. All right, so I'm going to do a few examples here. I'm going to do a couple, and I'll have you do a couple. We're going to evaluate f of 0, f of a half, and f of negative 2 for all these functions. All right, so f of 0 for this first example. So what this means is it wants me to plug 0 in for x. So negative 2 times 0 plus 1. That's 0 plus 1, which equals 1. So that's it, 1. It's an evaluate, which means you should get a single answer at the end, a numerical answer. All right, f of a half. So negative 2 times a half plus 1. All right, well, the 2 and the 1/2, the 2's cancel, so I have negative 1 plus 1, which is 0. All right, and then f of negative 2 is negative 2 times negative 2 plus 1. All right, that's 4 plus 1, which is 5. That's it. You just plug it in, figure out what it equals. That's all that notation means. Okay, if you're given a graph, this is kind of an interesting way that they like to do this problem. So f of 0, you go where x is 0. So this is where x is 0 on the x-axis, but we don't want to know that. We want to know what is the y value where x is 0. So you kind of have to like map it up to where the graph is. So 0 maps up to right here. What's the y value there? 3. F of 0 equals 3. All right, f of a half. All right, so I go to x equals a half, which is like right there, and see how the graph crosses. So it's right at 0. All right, now when we're getting the answer, we're looking at the y-axis. So where does this graph cross at the y-axis? That's at 0. All right, so f at negative 2. All right, negative 2 is here. Where's the graph crossing the y-axis? Looks like it's at 4. All right, try these last two, pause the video, and then come back and see if you got them right. All right, so I'm just going to run through these real quick because I'm running out of time here. All right, so first one is going to be 8 because 0 zeroes that out. Half of 4 is 2, so 8 plus 2 is 10. And 4 times 2 is 8, plus 8 is 16. All right, over here, f of 0 is going to be 0 because both of those 0 out. F of a half, let's see, we get a fourth minus 2, which is going to equal negative 7 fourths. And then f of 2, 2 squared is 4 minus 8, which is going to be negative 4. Okay, on the half real quick, 1/2 squared, you do 1 squared is 1, 2 squared is 4. All right, 4 times a half, that's 4 over 2, which is 2. And then you can turn that into an 8 over 4. And then I did 1 minus 8.